Assalamu alaikum everyone. I would like to say you all a warm welcome in this video. I will trying to make you understand practical one, that is Vernier Caliper. Yes, of course, it is according to new scheme of 2022. So in this video, we will learn about practical number 1 of physics, that is Vernier Caliper. I have highlighted here Vernier Caliper. Before starting this experiment, before starting of this video, let's begin with the marks distribution of 2022. So here it is a journal marks of is 3 marks, the VIVA marks is 4, and the practical performance marks is 8. The total marks is 15. So you have to perform 15 marks practical. In this video, we will follow the book of class 9. The publisher of this book is Dr. Saifuddin. So before starting this video, we will let's begin with the experiment 1 of class 9, that is measure the length and diameter of solid cylinder with vernier caliper and calculate its volume. So our object name is vernier caliper. The object name is what? Vernier caliper. So let's begin with the before starting our experiment. First we'll have to learn how to read the scale. So basically there are two scales on vernier caliper. One is main scale and the other one is vernier scale. So before starting, first we will see how to read the scale on board, and we will do it practically with operators. So let's begin with the board work. So as I told you that vernier scale has two scale. One is main scale, as you already seen on this board, and the other one is vernier scale. So before starting, I want to let you know that the vernier scale has two scale. One is main scale, which is in centimeter, and that it is same as your scale is the same scale which is in your pencil pouch scale, in your pencil pouch, yeah, or then in your geometry box. So vernier scale is always in vernier scale's main scale is always in centimeter, whereas vernier scale has no unit but it is in division. Okay, it has 10 division like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, not more than 10 in it. So how to read this scale? I mean to say that how to read main scale. So 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 6, 7, 8, 9, and then 1. Then it continues same as I read before, like 1, 1.1, 1.2, and so on. In this way the scale is continue. This dot means the scale is continue and so on. So my point is that then how to read main scale. The rule of reading of main scale is the zeros of vernier scale coincide with any main scale division. It is your main scale reading. Let's see here what I am trying to make you understand. The zero, the red one, this zero, this is vernier scale. The red scale is vernier scale, whereas the black marking is represented main scale reading. Okay, this is vernier scale and this is main scale. The zero of vernier scale coincide with the any division of main scale. the 0 of vernier scale coincide with any division of main scale. This is division. This 0 after 0 is 0.1. This is called division. This is called another division, and so on. So 0 of vernier scale coincide with any division of main scale is your reading of main scale. That I am trying to make you understand. So here, what is our main scale reading? Let's try to understand. Try to understand 0, 0.1, 0.2, 0.3, 0.4 and 0. Scale that I am trying to make you understand. So here, what is our main scale reading? Let's try to understand. Try to understand 0, 0.1, 0.2, 0.3, 0.4 and 0.5, which means that my main scale reading is 0.5. So my main scale reading is that is also represented by MSR is 0.5 centimeter. Is 0.5 centimeter, which means that my main scale reading is 0.5 centimeter. I hope you will understand. So here I have written for you again main scale reading is, which is also represented by MSR. We have find that 0.5 centimeter. I hope you all are clear. So now it's time to read Vernier scale. So the rule of Vernier scale is that the two division, one division of main scale and the other one division of Vernier scale. I mean to say that like 0.5 of main scale and the 0 of Vernier scale, both are coincide at the same time. That means the Vernier scale reading should be 0. Let's understand by another example. If two divisions, one division of main scale, any division, no matter which one is main scale division and which one is vernier scale division, but any division of main scale and any division of vernier scale except 0 and 10. If 0 is coincide with one main scale division and at the same time 10 is also coincide with that main scale division. Look at here, like 0.5 is coinciding with 0 of Vernier scale. On the same time 1, 1.1, 2, 3, 4, 5, 6, 7. 1.7 is coinciding with 10. At that case, we will consider another division of Vernier scale, which is best coincide with main scale. Okay, so here we will going to look which one is coinciding, and at the same time 10 is also coincide with that main scale division. Look at here, like 0.5 is coinciding with 0 of Vernier scale. On the same time 1, 1.1, 2, 3, 4, 5, 6, 7. 1.7 is coinciding with 10. At that case, we will consider another division of Vernier scale, which is best coincide with main scale. Okay, so here we will going to look which one is coinciding except 0 and 10 on Vernier scale. So 0 is coinciding and 10 is coinciding, so we are not going to consider these two divisions. So except of these we are going to consider. So which one is best coinciding? Best coinciding means one, the main scale division and the vernier scale division, both are coinciding with in this way. So we will consider that division. So 1 is not coinciding, 2 is not coinciding, 3 is not coinciding, 4 is also not coinciding, 5, 6, 7 are also not coinciding, but 8 and 9, The base coinciding is 8. So here I am going to taking the vernier scale reading is, which is also represented by VSR, that is 8. Here I am not writing any unit because vernier scale has no unit. So I will write what here? I will write here division. The short form of division is DIV. You can also write full form of division, but for the sake of saving our time, we will write DIV, only DIV. Okay, hopefully you will getting my point. Now we are going to do this practical or this experiment with the apparatus. So let's begin with apparatus. I hope you will understand up till now. I will now trying to make you understand with apparatus. Then we will do note the all reading and making the observation table in practical book or practical journal. So here it is. Okay, just as I told you, we will perform with apparatus now. So here is our apparatus, which is called Vernier Caliper. Why we call this apparatus Vernier Caliper? Because the scientist or inventor name is Vernier, and the caliper means to caliper something or to measure something with this apparatus. I hope you will clear and not confused with this apparatus. We will discuss further about this apparatus, but right now I will tell you how to write the apparatus in your practical journal or practical manual. So this is experiment object. This is object of your experiment. Okay, this is the object of your experiment, and this is the apparatus, the material which is required to perform the practical. What is your requirement to perform the practical? One is vernier caliper, as I show you. This one is vernier caliper, this is your requirement, and the other one is solid cylinder. This material is called solid cylinder. So you don't need to write the theory in your manual or practical journal. The which thing you have to write? The experiment you have to write, the apparatus you have to write. Don't need to write, as I told you earlier, theory you don't need to write. This thing is also not required. You have to write formula, method, and measurement of length, observation, then this formula, length of cylinder with observation table, mean length, then diameter of cylinder observation table, then mean of diameter formulas, then calculations, and after that last thing is result. You have to write last thing is result. One more thing is you have to draw this figure in your practical journal or manual, but this one is not required. Okay, you don't need to draw this one figure, you have to draw this figure. Okay, I hope you all are clear. So one more time I am going to read for you. Measure the length of diameter of solid cylinder with vernier calipers and calculate its volume. So what are requirement? Our requirement is vernier caliper. Yes, it is. Yes, we have this apparatus, vernier caliper. You don't need to worry about. I will discuss you in detail with this. Then formula. What is the formula? The formula is to find the volume of a cylinder is volume of cylinder is equal to area of cross section into length. We can write this formula in this form: V, capital V, equal to pi which is represented to area of cross section pi r square. Okay, area of cross section is represented by pi r square, and after that in multiplication form you have to write length, which is represented by small l. You don't need to write method in your practical journal. Okay, so don't need to write method and measurement of length. One is correction, one correction I have discussed, you need to discuss. So you have to directly note down observation on your blank page of your practical journal. Length of main scale division 1 millimeter. You have to copy, basically you have to copy this thing in your practical journal. But don't worry, I will discuss you before discussing the with operators. I have to discuss this thing which is you have to note in your practical journal. So don't worry about your operators. I will discuss with you in detail. So here it is your apparatus. So first of all I will discuss about this apparatus. What kind of this apparatus is this? So what is the purpose of this apparatus? The purpose of multi-purpose of this apparatus is used for multi-purpose. There are some the name of this apparatus is, as you know, vernier. So this, what are these things? These are called upper jaws. These are called upper jaws. What are called this thing? These are called upper jaws. What is the purpose of these jaws? To measure the inner diameter of object. To measure the inner diameter of object. In this way, these two things are called jaws. But which jaws? Lower jaws. But which jaws? Lower jaws. So what is the purpose of these jaws? The purpose of these jaws is to measure the diameter of object. To measure the outer diameter. The upper jaws measure the inner diameter, whereas the lower jaws measure the outer diameter of any object. So next thing is this one. This one thing is called depth gauge. What we call this thing? We call this thing is depth gauge. Which is measured by vernier. Okay, as I told you earlier in starting, in vernier caliper we have two scale. One is main scale, the constant scale, and the movable scale, which is movable scale is called, the movable scale is called vernier scale. Okay, the movable scale is called vernier scale and the fixed scale is called main scale. This is the same as in your geometric box or pencil pouch. This scale, the fixed scale, is same as it is in your geometry box or pencil pouch, but this is the movable scale. The movable scale we call it vernier scale. Okay, and this one is lock. This is used for lock. When I tied this screw, the vernier scale can't be moved. Okay, I hope you all are clear. So let's move ahead. So okay, let's start with the observation. So what is written here? Length of one main scale division is equal to 1 millimeter. So what does it mean? Is in centimeter. So here it is written length of one main scale division is 1 millimeter. What does it mean? After 0, look at here, I think it is visible for you. So after 0, one division is marked, which is mean that 0, 0.1, say. Okay, then what does it mean? 1, it is in millimeter. Then 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.8, 0.7, 0.8, 0.9 and then 1. It is all these all divisions are in millimeter. If you want to find the answer, your answer in centimeter, so you have to divide this one by 10. So let's see what is the answer of one division in centimeter. So let's do calculation. So I write 1 divided by 10. So answer is 0.1 centimeter. So our answer is 0.1 centimeter, which means that we are doing in a proper manners or proper way. So in next step they are saying that total number of vernier scale division is equal to 10. So let's see this, either they are saying right or wrong. So let's look at here. 0, after 0 this one mark is called 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have to follow this scale. We have to follow this vernier scale, not upper one. We have to follow lower one, because we are taking all reading in centimeter, not in inches. Therefore we have to follow this one scale, okay, not upper one. Must remember that. Okay, so there is one more thing written here, that is least count. What does it mean? So I hope you know very well, but here I am explaining for you the least count. Least means the least value which is you can count. Okay, mostly people do mistake that when they asked by someone what is least count of any instrument, they said that 0. You are right, but you can count it. After 0 you can count any other measurement like 0, 0.1. Okay, so 0.1 is the least count of the main scale or vernier scale which is readable. After 0 you can read or count 0.1, which means that the least count of vernier scale is vernier caliper is 0.1. Okay, then length of one main scale division, length of one main scale division divided by number of vernier scale division. MS stand for main scale, whereas VS stand for vernier scale. So least count, we have the formula. This is formula. So what is the formula of least count? The total, so length of one main scale division divided by number of vernier scale division. How many divisions we have on vernier scale? We have 10 division on vernier scale, whereas we can count on main scale 1 division. So which is the what is the division number is? We can count it here 0, 0.1, which means that least, the formula of least count is main scale we have count 0.1 divided by total number of division on vernier scale. So here is 10, so 0.1 divided by 10, so least count is 0.01 centimeter. When you will take the ratio of 0.1 and 10 is come out 0.01 centimeter. So one more thing is, so here is one term is used, zero error. So must remember that in every instrument has error. Here one I got a question that how many type of errors. I hope you learn in your class. So please answer your please answer in the comment section of there are some kind of error. Which of them? One is zero error. Zero error is two types. One is positive error or other one is negative error. So every instrument must have zero error or error. But in our case I have removed this error for you, because for the sake of saving our time. So how to find that in either in our instrument has error or zero error is present or not. So how will you find? You can find in this way: if your vernier scale 0 and the main scale 0 is not coinciding with each other. If they are both not coinciding with each other, that means there is zero error. But right now we don't have zero error in our instrument, because I have removed for you for the saving our time, for the sake of saving our time. So if there is any error, let's suppose there is positive error. So our vernier scale 0 is not coinciding with this 0. So where it is, then this 0 is come before the main scale 0. Then in case of negative error, what will happen? The vernier scale 0 is not coinciding again main scale 0. Then where it is, the vernier scale 0 is coming after the main scale 0. Okay, the vernier scale 0 is coming after the main scale 0, which means there is negative error in both cases. If positive error, if you find positive error, you will subtract the divisions in positive error. When it is negative error, you will add the divisions in negative error. Okay, in this way you can remove zero error in your observation. Okay, if you find any error in zero error in your apparatus. But in our case I have already removed for you for the sake of our time. So what we will write here? 0. We will write here 0, because in our case there is no any kind of zero error. So therefore I have write here 0. Length of cylinder, you have to draw this observation table, complete observation table, on your blank page of practical journal. So let's see what are the observation table headings. One, so total length is of what? Length of solid cylinder. So total length L is represented by L, length is represented by what? L, equal to MSR plus fractional part. MSR reading plus fractional part reading, both are adding, which is equal to total length. Okay, last column. In last column we will cut, we don't note this column, because we in our case we don't have a zero error in our apparatus, as you know. Okay, therefore we don't make this column. So in your case you have a zero error, so you have to draw this column. And as I told you, if you have found a positive error, so you have to subtract the reading from your total length. If you find the negative error, you have to add the reading in your total length, then you write corrected length. Okay, otherwise if you found the error and you don't do this thing, in this way your reading will wrong. So these are the sample reading, you don't need to write this thing, but it is our help, it is for our help. So we will do this for our practical. So how to perform this reading? You have to find the length of cylinder. So how to put your solid cylinder? This is solid cylinder. So how to operate this? You have to take this solid cylinder and fix between this lower jaws. Okay, you have to fix this between lower jaws. Then you have to screw tight, because you can manage or handle it without any resistance or any problem. You have to fix it between these jaws and then screw tight in this way. Therefore you cannot face any kind of problem. Now you have to read the scale. What scale? One is main scale and other one is vernier scale. You have to read both scale. How to read? I have told you in our starting video. You how to read. Let's do it again. Read it again. The vernier scale 0. The vernier scale 0 is coinciding by main scale of any division. If vernier scale 0 is coinciding by any division of main scale, so what is our reading? That is our reading of main scale reading. So in our case, I hope it is visible for you. So let's see. This is 2, 2.1, 2.2, 2.3, 2.4 and 2.5, 2.6. In our case 0 is coinciding with 2.6. It is not necessary that you also find the same reading, because it is depend on your instrument. Every instrument has different reading, so you don't need to worry my reading is not coming the same, not finding the same, but here is different and your reading is different, so you don't need to worry. But if you follow the same method, you will find the correct reading. It is depend on, it is actually vary the instrument, okay, the instrument, and it is depend on the instrument. So in our case 2.6 is the main scale reading. Okay, one more thing, if you find the main scale reading is 2.6 for the length, then must remember that the whole time you have to perform this reading 3 times. So you must remember that 2.6 never be changed in for this scale, okay. But vernier scale can be changed or cannot be changed. Sometime it change or sometime it not change. It depend on material. Let's see what I am trying to make you understand. So when you find the length, you will write 2.6 3 times, or how many times you have to perform. If you find the reading main scale reading 100 times, the main scale reading will be same for 100 times, okay. So if you want to verify that, you can check, no issue at all. So we have find main scale reading. Now it's time to find the vernier scale reading. So make sure that we have find the main scale reading in decimal form, okay, 2.6, but it is not in vernier scale. In vernier scale the reading will find in constant form, not in decimal form or fraction form, okay. So don't need to worry about our solid cylinder is released from this vernier caliper, because I have tied the screw, therefore vernier scale reading is fixed, okay. So let's find the reading for vernier scale. I have told you the best coinciding value is the reading of vernier scale. Let's look from 0. 0 is coinciding with any division of main scale, which means that 10 is also coinciding. So in our case 0 and 10 is also coinciding, therefore we have to see another reading except of 0 or 10. So 1 is not coinciding, 2 is also not coinciding, 3 is not coinciding, 4 no, it is not coinciding, 5 no, it is also not coinciding, 6 7 no, but in our case 8 here. What a coincidence. In starting video I have taken 8, but in our case is also vernier scale reading is 8. So here I have write 8, okay, but not any unit, okay. it is not, it does not have any unit. It is division form. Okay, 0 1 2 3 you can count, not in a decimal form. Okay, so you have to write 8 divisions. Now come again. Now come again, you have to fix it again as I told you earlier, and you have to tighten the screw. No worry about if it's released from the vernier scale, because our reading is fixed by this screw. So it's happened sometime. So what is the reading of vernier scale on main scale? Let's see. See, look at here, it's fixed again 2.6. As I told you earlier, it is fixed for whole time. Then what is the reading? It's before I taking the main vernier scale reading, I told you it's sometime change or sometime not be changed. So look at here, either is this time change or not. 0 is coinciding, which means that 10 is also coinciding. So except of both reading, you have to note another reading. 0 after 0, 1 is not coinciding, 2 3 4 5 6 7. Oh, 7 8. Okay, this time 9 is coinciding, 8 is not coinciding properly. So you have to perform this reading performance again. So in this way you can find the third reading. Okay, now I am fixing it again for vernier, taking for the sake of vernier scale reading taking. So here I am fixing the one solid cylinder and tighten the screw. No worry, it's happened. But again you can see that our main scale reading is constant, which is 2.6. I have already written. Our vernier scale reading is 8, first reading 8, second 9. Now you can see that 0 is coinciding, 10 is coinciding, which means that, sorry, 0 is coinciding, 10 is coinciding. Now see except of these two readings, 0 is also coinciding, 1 is not coinciding, 2 3 4 5 6 7 8 9. This time 9 is not coinciding, but this time is 9 is not coinciding, but 8 is coinciding. It's happened, the reading will repeat, the reading can repeat. Okay, so you can write 8 it again. You no worry about the my reading is repeating, so either this I am performing right or wrong. You are performing right. Okay, you don't worry about this. So reading can be repeat or can't be repeat, sometime it's happen. Okay, so you don't worry about it. Okay, now it's time to calculate the fractional part. How to calculate the fractional part? They are giving us a formula. Fractional part is equal to vernier scale reading multiplied by least count. So fractional part is 8 in our case. Vernier scale reading is 8 multiply by least count. What is least count? Or in our case 0.01. So 8 multiply by 0.01. To finding the 8 multiply by, which means 8 is what? Vernier scale reading multiply by least count. What is least count? 0.01. 0.01. So what come out? 0.08. 0.08 already written, centimeter unit is already written, therefore I am not writing here. If you want to write, you can write centimeter, but once in write, you don't need to write it again. Now 9 multiplied by least count, which means is 0.09 centimeter. 8 multiplied by least count, 0.08 centimeter. Now it's time to find the total length. The formula of total length is main scale reading plus fractional part. What is our main scale reading? 2.6. 2.6 plus fractional part. So 2.6 plus fractional part. What is our first fractional part? Is 0.08. So 0.08 is equal to 2.68, 2.68, 2.68, because here are both reading are repeating. So let's do for second reading 2.6 plus 0.09. So 2.69. The answer is 2.69. Okay. Our first observation table is completed. Now mean length. How to find mean length? Here they are giving us the formula. Total length equal to L1 plus L2 plus L3 divided by 3. So this is our L reading. You have to find mean length, this which means the length table, length column. So length 1 is 2.68, 2.68, second length is 2.69, and third one is 2.68. Now it's time to add these three reading. What is our first reading? 2.68 plus 2.69 is second reading. Now third and last reading is 2.68 is equal to 8.05, 8.05, and the last thing is you have to divide these three reading by 3. So now I am dividing 8.05 divided by 3. So answer is 2.68, 2.68. Okay, I hope it is clear up till now for you. Now it's time to make measuring the diameter of cylinder. Now it's time to measuring the diameter of cylinder. How to find the diameter of cylinder? It is quite easy as measuring the length of solid cylinder. So let's start from solid cylinder. Measuring the diameter of solid cylinder, you have to fix it in this way between these jaws. In what jaws? In lower jaws. You can fix it like this, and you can also fix this like this. Wait for a while. You can fix it like this. It's up to you. In both cases you can find the diameter of a solid cylinder. Okay, must remember rules, all rules, as I told you. Once the main scale is comes, it will be same for all time. Okay, so how to read the main scale reading? You can read the main scale reading. How? The zero of vernier scale is coinciding with any division of main scale. So here is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 6, 0.7, 0.8. In our case, the main scale reading is 0.8, which means the reading is same throughout the diameter of solid cylinder. Okay, now it's time to measure the vernier scale reading. How to measure the vernier scale reading? You now very well know the best coinciding value is the vernier scale reading. Which one is the best coinciding reading? The main scale reading, and the vernier scale reading is best coinciding reading is the reading of vernier scale. So 0 is coinciding, which means 10 is also coinciding. After 0, 1 is coinciding, 2, 3, 4, 5, 6, 7, 8, 9. No, let's see it again. 9 is not coinciding, 8 is not coinciding, 7 is not coinciding, 5 is not coinciding, 6 is not coinciding, 4 is also not coinciding, 3 is not coinciding, 2 is not coinciding, but 1 is coinciding. You can see here 1 is coinciding with main scale division. So here I am taking the vernier scale reading is 1. Sorry, I have to write one time 1. So for second reading, what I have to do? I have to lose it from vernier scale and fix it again and tight the screw from the top and take the reading it again. As I know it very well that main scale reading will be same, therefore right now I am not looking for a main scale reading, but I am focusing on vernier scale reading. So 0 is coinciding and 10 is coinciding, as we all know that after 0 and 10 which one is coinciding right now. 2 is not coinciding, 1 is coinciding, but 2 is not coinciding. 3, 4, 5, 6, 7, 8, 9. These all reading are not coinciding, but 1 is coinciding. Therefore, I am again taking reading of vernier scale is 1. So again I am losing this screw and so fixing the solid cylinder for determining the diameter of solid cylinder. So here I am tightening the screw diameter. Now again I am not focusing the main scale reading because I know the main scale reading will be same, that is 0.8. So I am focusing on vernier scale reading. 0 is not 0 is coinciding, 10 is coinciding, so 2 is not coinciding, 3, 4, 5, 6, 7, 8, 9 is not coinciding, but 1 is coinciding. So 1 I am taking again 1 as a reading of vernier scale reading. So I hope you will be clear. So it's happened, it can be repeated, as I told you earlier, the reading can be repeated or sometime, but and cannot be repeated sometime. So it depends on any instrument. So you don't worry about this repeating, this reading are same. So you can now find the fractional part. I hope we how to find fractional part. Fractional part is equal to vernier scale reading multiplied by least count. So what is the vernier scale reading? 1, and the least count is 0.01. So 1 multiplied by 0.01, then you will find the fractional part reading, that is equal to 0.01. It's a coincidence because anything you will multiply by 1, it's comes same. So least count is also the same, 0, that is equal to 0.01. So you don't need to worry, so it is same for all. So I have written here. So now it's time to find the diameter, total diameter. So diameter is equal to main scale reading plus fractional part. So what is our main scale reading? Our main scale reading is 0.8. So 0.8 plus fractional part, or what is the fractional part is 0.01. So plus 0.8 in 0.01, 0.8 plus 0.01. So our reading is 0.81, which means that the diameter of solid cylinder is 0.81. What does it mean? The diameter of solid cylinder is 0.81. At last, because in our case there is no zero error, therefore we will not draw this column of corrected diameter. Now we have to find the mean diameter. So the formula of mean diameter is equal to capital D equal to D1 plus D2 plus D3. This is D1, this is D2, and this is D3. So write down here 0.81, 0.81, 0.81. When you will add these three readings and divide it by 3, you will get again 0.81. So you can calculate it for your knowledge. Now I am going to find the calculation. It is the most important part of the practical. Okay, you have to perform for gaining the marks. As I told you, it is I think it is about 8 marks. It is about 8 marks. So here you have to find the radius of cylinder, but in our case there is no any kind of radius, but we know that the formula of radius is the half of diameter. What is the formula of radius? The half of diameter. We have learned it in earlier classes. The formula of radius is the half of diameter. The half of the diameter is called radius. The half of the diameter is called radius. So diameter का half है 0.81 0.81 divided by 2. So 0.81 divided by 2, then you will get 0.405. What will you get? 0.405. Now it's time to find the volume of a cylinder. So formula of volume of a cylinder is V equal to pi, which is constant. I will tell you the constant value of pi. Right now let's move ahead. The formula of volume of a cylinder is V equal to pi r square L, which is the mean length of which L is represented the mean length of a solid cylinder. So the value of pi is 22 upon 7. 22 upon 7. What is r? What is the value of r? We have find that 0.405. So we will write here 0.405 square. So we have to find the square of 0.405. Then you will get the answer of 0.405 square is 0.164. You don't need to write the whole value of this. You can write only 2 digits value, because why I am saying to you, the least count of Vernier caliper is 0.01. After decimal value you will take 2 digits. Therefore here we can also take 2 digits. So here I am writing that 22 upon 0, the square of 0.405 is 0.16. Then the mean length is 2.68. So 2.68. Now I am multiplying the whole value. What I am doing, 22 upon 7 multiply by r square value, which is the 0.405 square, which is come out, the answer of 0.405 is 0.16 multiply by 2.68. So answer is 1.347, which means that the volume of a solid cylinder is 1.347. Now the time to write the result. Length of the cylinder is, you have find 2.68. The length of cylinder you have find 2.68. Note down here 2.68. Now what is the diameter of a cylinder is 0.81. Note down here 0.81. Now last thing, what you have find that volume of cylinder. So the volume of a cylinder is 1.347. so you can write 1.347 in centimeter. You must remember that length is in centimeter, diameter is also in centimeter, but volume is in centimeter cube. Okay, so here is our apparatus reading, and we have done our first practical, alhamdulillah. So in this way, if you note this, I hope you will be cleared and understand the whole reading. Please don't forget to like, share and comment my video. So please like, share and comment in my video. I will uh, uh, I will provide you the further detail, further things in description, so you don't need to worry about. Thank you. Allah Hafiz.